We're always told that math is something you learn, but what if it's actually something you do? Well, today, we're going to take applied math right off the textbook page and put it into action. I'm going to show you how it's already the super powerful tool you're using like every single day.
Now come on, we've all been there, right? Staring at some crazy equation in math class and thinking, when will I ever use this? It's probably the biggest frustration with math. And you know what? It's a totally fair question. But I think the answer is going to surprise you.
So here's the deal. The whole problem is that, a lot of the time, school math just feels, well, disconnected from real life, doesn't it? We learn about X and Y and all these theorems, but it's like, okay, how does this help me with anything? Well, that's exactly what we're here to do, bridge that gap. Okay, but here's the cool part. You are actually already an applied mathematician. Seriously, you just might not know it yet. Every single day, you're using all this foundational math to solve little problems and make decisions, and you're probably not even thinking twice about it. I mean, just think about it for a second. When you're in the kitchen and you double a cookie recipe, that's you working with proportions. Or when you're shopping and you spot that 30% off sign and figure out the price in your head, you're using percentages. Even just following a map or getting sucked into a puzzle, that's all spatial and logical reasoning. In all these moments, you're doing math without even realizing you're doing math.
So, what's actually in this secret toolkit you've got? Well, it's all the big ones, ratios, percentages, even the basic logic of algebra. And here's the key. These aren't just some abstract ideas from a textbook. Nope, they are the real, practical tools that power how you solve problems every day.
All right, to make this super clear, let's zoom in on just one of those tools. Let's talk about ratios. We're going to see how this one simple idea can be used to scale things up, from something small and easy to something way, way bigger.
So first off, what even is a ratio? It's really simple. It's just a way to compare two or more things. The classic example, of course, is baking. If your recipe says you need 2 cups of flour for every 1 cup of sugar, boom, that's a 2-to-1 ratio. It's just about the relationship between those numbers.
Okay, that's cool for cookies, but let's take that simple idea and apply it to something a little more exciting. Let's say we're going to design a skateboard park. Now this is where a tool like ratios becomes incredibly powerful.
So here's the game plan broken down into 4 easy steps. Step 1, what's our goal? We want to build a miniature model of a ramp. Okay. Step 2, what do we know? We've got the data. The full-size ramp is 10 feet long and 4 feet high. Got it? Step 3, what's our ratio? We're going to scale it down to be 10 times smaller. So the big question is, how do we figure out the model's new size? Well, that's step 4, the solution. We use proportions. All that means is we're going to keep the relationship between the length and the height exactly the same as we shrink it all down.
And check this out. Here's the solution. By keeping that ratio perfect, we figure out that our model ramp needs to be 1 foot long and 0.4 feet high, which, by the way, is just under 5 inches. The shape is exactly the same as the real ramp, just perfectly scaled down. See? That's the power of using a simple ratio.
And listen, this isn't just some random classroom problem. This is literally what artists, designers, and civil engineers do every single day. They use this exact kind of math to design and build massive structures, making sure everything is perfectly in scale. So with this one skill, you're actually thinking just like a pro.
Solving a problem like that, it feels pretty powerful, right? It just goes to show you the real key isn't just memorizing a formula, it's knowing how to apply it. And that simple idea is totally changing how math is being taught. It's shifting the focus away from abstract rules to a much more practical, hands-on way of learning.
So what does this new approach actually look like? Well, for one, it's mastery-based. And what that means for you is no more being left behind. You only move on when you've really truly got it. It's also at your own pace, so you can learn as fast or as slow as you need. And maybe most important of all, it uses visual tools. Because actually seeing the math happen is way more helpful than just staring at a bunch of numbers.
And to make all this happen, there are these amazing digital tools out there. Like, some of them let you use these virtual blocks and tiles so you can literally build a ratio and see what it looks like. Others are all about collaboration, giving you a space to talk through problems with other people and really sharpen your critical thinking skills.
And all of this kind of brings us to the real heart of the matter, the most important point of all. Because when you learn math this way, by actually doing it, seeing it, and applying it, you're not just learning equations. You're learning something so much bigger. You're learning how to become a real problem solver. Because let's be honest, the end goal here isn't just about getting the right answer on a test. It's not about memorizing formulas. The real prize, it's something way more important. It's about becoming a proficient and a confident problem solver.
It's about building the skills and, just as importantly, the mindset to look at any challenge, in any part of your life, and have that feeling that you've got the tools to figure it out. Now that is the true power of applied math.
So that really just leaves us with one final question. A pretty empowering one, I think. Now that you can see this math toolkit you already have and you know how to use it, what problem are you going to solve next?